Hello and welcome everyone to May's KMC Controls Stuck on a Bucket webinar. I am joined by our infamous Billy Gayton, training manager.
Hello.
This month. And we're going to be talking a little bit about BACnet today with a kickoff on a series on networking. And there'll be a 3-part, maybe 4-part, depending on how things go and if we need to extend things out to cover more over. But this first one will kind of be a cover over the basics of BACnet that if you caught the series we did or the couple episodes we did last year talking about BACnet, some of this will be redundant, but kind of want to cover it again, get a base covering of understanding of BACnet and the different parts and pieces of it this time. And then the second part will be taking a look at Wireshark captures with Dave Bowman, how to take one and then what to do with it once you've got it, and some other features and new tool that's in the works there that those guys are working on. So that's good. And then that third part that we have on the docket now is kind of a conversations with the IT guy as a part of the networking, and kind of cover and talk about what IT usually wants to know as far as what devices you're installing, what's the operating system, what ports are you using, any LANs need to be protected from the BMS side, how much traffic, and then we'll talk a little bit about what kind of questions you can prepare yourself for so you sound a little more intelligent as you're going into those conversations with the IT guy. What are my clients and servers? What are the IP subnets that I need? What kind of information do I need to have and be prepared for? So this is a first part in our series here, and that's just a little tease of what the second and third parts for June and July will be. So again, we raffle off. We've been having a series of these Yeti cups. So if you stick around to the end, make sure to keep an eye out for an email to see if you happen to have won that Yeti cup this month. Last month, I believe it was Nate Barker with United Mechanical won the Yeti cup. So it is true there are people winning them. In case you haven't won one yet, don't worry, keep attending. We got to draw you in some way, if it's even just for a free Yeti cup. That's what we'll try and do. So, all right, let's dive into it a little bit here. Some of this stuff I'm going to kind of breeze through again, since we're kind of covering this stuff. If you guys know BACnet, I'm not going to spend a whole lot of time, but we just want to touch on the basics. With BACnet, the beauty of it really is you're not tied down to a single company or device. The standardizing made it possible to consolidate workstations and allow shared data to be able to flow from one place to another rather than being stuck with vendor-specific platforms. And what's cool with BACnet is it's not just a communications protocol. A lot of times, right, when we talk about BACnet, the first thing that comes to mind is just that communication protocol, but it also defines and describes the devices on the networks and then those objects and services that those devices provide. There's a whole list of standards that are written out, and KMC prides itself on holding to those standards almost to a T with a lot of stuff, to where some of the things don't quite make sense to me, but they match the BACnet standard. I think it's with some of our digital input switching in my mind, seems backward of what a input would have normally closed being on and off. I think, Billy, right? Isn't that the one that is usually, at least in my mind, different than I'm used to seeing, but it matches the BACnet standard. So, so there's a lot to BACnet. And, you know, if you're ever bored, of course, there's all kinds of information out on the official BACnet website, where you can go and read through a standard set of properties, maybe help you get a good night's sleep by just start reading through some of that stuff. What else? Let's move on. All right, so our BACnet networking, we've got 4 types of BACnet, primary types, right? We've got BACnet IP, Ethernet, BACnet MSTP, and BACnet ST. The 2 most prevalent LAN types used today are BACnet IP and BACnet over MSTP. The difference between TCP and UDP really is, I guess, let's see, UDP is important because it's a protocol that BACnet, many of the emerging IoT protocols use, but they allow messages to communicate across multiple subnets. So a little deeper dive into it there. The IP allows for transmission of data, applies addresses to devices, allows for creation of logical subnets. The UDP is a connectionless protocol, allows for small packets that are non-network intensive, and then TCP verifies that data transmission and has a built-in error correction. The BACnet Secure Connect is an addendum that was added to the BACnet protocol. It was released by the BACnet committee. It's a secure encrypted communication data link layer. It's specifically designed to meet requirements and policies and constraints for minimally managed to professionally managed IP structures. What else? BACnet IP allows for communication across multiple subnets. I think we mentioned that. So you see that quite often for multi-campus control systems, and it can utilize the benefits of fiber and Giga Ethernet, as well as assigning IP addresses to devices. So we see that more and more prevalently coming up in network systems. The TCP, it must be established a connection to a device before transferring data. So it's not just sending data out. However, most of the existing BACnet systems out there, BACnet networks, are going to be wired MSTP, which uses that RS-45 twisted pair serial cabling. And it's used for those local low-speed networks that are wired in parallel. And then communication just goes from one device to the next, and so on and so on. Anything there you think I might have missed, Billy?
Sounds good so far.
Yeah. All right. Let's dig a little deeper here, BACnet networking. In the case of, multiple buildings with IP subnets or multiple subnets, you would want to use BACnet routers. They have a special function called a BBMD. And with that BBMD, which is a broadcast management device, it's a way to tunnel BACnet broadcast messages from one IP subnet to another in the form of directed unicast messages. BBMD is needed because IP routers block broadcast messages. And so in BACnet, those messages are essential to discover and communicate between devices. That's how we get important information from building 1 to building 2. So those BBMDs are important, right? Looking at clients and then servers here. The clients can initiate requests, right? For example, like a controller or front end requesting point information. And then you've got servers which respond to requests from clients. So there's a lot of great information if you haven't ever looked it up. We've got an application guide out on our website that talks all about broadcast management devices, BBMDs. It goes through example tables. The application guide number there is on the page, so you can go through and look at that, download it, use it as a reference for if you're setting up a new system and have questions. So good information to have there. Next, we'll move on. We'll look at a little bit different MSTP and 45 peer-to-peer communication protocol. So this just means it's communicating with other devices on the network. Is that peer-to-peer? That token is passed in sequence based on MAC address. So it goes 1 to 2, 2 to 3, and so on down the line. And that token takes that information in the form of a pulse signal that's passed between devices on a network. Some key points here: only the device with that token can communicate. So it's like a group of people standing in a line. If they all try to talk to one another, communications is not going to be great. But if you give one person a microphone and they are the only person who can talk, right, communication gets a lot better. There are rules that dictate how long the device can have the token, how much information it can transmit. And then the controller with the lowest MAC address generates the token. So I don't have my router pulled up, but this is a good example where you can use a lot of the information screens in our BAC 5051AE router to look at that token passing, see what the time delays are as it's passing through the network, see if it's getting hosed up because the max master is not set, things like that. So that's where a lot of that information really comes in handy. It's not just some cool screens that we built into the router. There's a lot of great information to pull and use out of those. All right, let's look at MAC addresses. MAC addresses, right, we're limited to 0 to 127. You can go up to 255, but 128 through 255 are slave devices, and KMC doesn't use slave devices. All our devices are set up as master there. MAC address can't be duplicated on a network segment. I'm sure we've all run into, let's back up here just one. I'm sure we've all run into situations with duplicated MAC addresses. And the joy that's going through and figuring that out. Practical device limit is 35 to 40 devices, but it depends on network load and network speed. What else? I think that's that there. Moving on with our addressing. As a rule of thumb, we like to leave max 1 through 3 left open for service devices and tools. So you start your controller max at 4, and then you address the controller sequentially after that. It's important to remember not to leave any gaps in the MAC addresses. You just get delays there as it's going through and trying to find a device in that gap. What else? When you're going through and numbering these, don't leave any gaps or big gaps in there. MAC addresses only identify a device within a single network segment. Duplicate MAC addresses are detectable within our router. I think I've hammered that one enough. Let's talk about device instances. Sorry, looks like my bullet points come in a little goofy here. So we got device instances. It's an address, right, that's given to a controller. Has to be unique across the whole BACnet network. So if you've got multiple networks, typically you'll have device IDs that are set up, and typically will include some octet of the IP address for the router that they're tied to, or some other form of sorting those out. You never want to have it be 0. You're available anywhere from 1 all the way up to 4 million there, so you've got a whole lot of options. From the factory, all of our Conquest controllers are set with the device instance 1 at the factory. And that's easily as changed if you have the Conquest or Connect Lite app to be able to set that device ID and MAC address with your cell phone. Using that app, before you even take it out of the box, you can adjust that controller so it's ready to go when you plug it in on the network, and you're ready to go. What else? Available network numbers. You got 1 to 65,000 some odd. I think that covers it there. All right, a few little general tips. Max number of devices on each of the networks varies by vendor. Typically 35 to 40. The maximum length of a BACnet MSTP bus is 4,000 feet. On systems with multiple vendors, multiply the vendor ID by 1,000 and then add the max. So this is just kind of an example here. So if you've got KMC Controls, max 20, device ID then is 28,020. So it's a way to differentiate between KMC Controls and, say, an Allergen controller. You use Allergen vendor ID and then come up with those device IDs, and that'll help keep separated there. It's always critical. It seems kind of redundant, or that it should be expected, but that polarity on that BACnet trunk or MSTP trunk is critical. It's amazing how many times that'll still throw folks up for a loop when they're out wiring a system up. And a lot of different contractors and vendors will use white for one side of the trunk and black for the other, and so you can get some interesting mix-ups there. So it's always important to kind of make sure where you're landing those terminals, just to keep you from having to go back out to controllers and rewire things. Always good to ground your shield as directed by the vendor. One other note here: if the receive light is on when there's no communication, going back to this polarity, there's a good chance that polarity has been reversed. Excuse me. And so that'll tie back to looking at the controller and identification there. What else do we have? Avoiding unwinding the twist of the cable when not necessary. Sorry, my points are coming in all over the place here. Let's start at the top. Set your max master. That's a big one. No, it doesn't always seem like it's that big a deal, especially when you're dealing with maybe a small network, but it can make a difference. So go ahead and set it. You can leave, a few past it in case you ever add devices. You got room and you don't have to change them there. But if you do have just 20 devices on that network, it's going to keep looking all the way up to 127 if you don't set that max master up. Going on to the next point here of avoiding the twist in the cable when not necessary. Twisting that insulated conductors around each other helps reduce that outward noise and improves the immunity to external noise picked up. No T-taps on the trunk. When adding new devices to an existing trunk, right? We want to make sure that we've got a continuous loop running through that device. Network wire communication is achieved through using electrical pull signal. When no end lines are installed, the pull signal reflects backward and collides with other data pulses. The resistor is what absorbs that pulse energy and dissipates it as heat. So it's good to set your end of line terminations. There is a reason that we, say set your end of line terminations, set your devices up, that little switch on there, if it has it, set it as end of line. Make sure you do that. There is reasoning behind all that. In most cases, if we, controllers don't have built-in end of line terminations, 120 ohms is a typical for end of line resistors, but some brands call for different ohm levels for the end of line termination. So it's good. Just go back and check your whatever brand you happen to be using or integrating with. Check with those to make sure you're going to get the best communication between your KMC controllers and allergen controllers or whatever it may be. Moving on here, the next note that some of y'all may know, everybody may know, we've got that net sensor data port that's on the bottom of the net sensor there that can be used as a way to configure and troubleshoot connecting to the MSTP trunk that net sensor is connected to. So it's a way to give you a look at that trunk. It's not going to go anywhere past the router that it's connected to, but it will show you that trunk of VAV boxes. If you don't have one, these cables can be ordered that have the little plug-in pin that fits that 4-pin slot on the bottom of the net sensor there, that data port that can be ordered off the website. And I thought I had the part number jotted down in my PowerPoint, but I don't see it. Billy, do you know the part number for that cable off the top of your head?
I don't off the top of my head, or I'll find it and I'll put it in the chat.
Okay. Sounds good. But it's just an easy way. You got a little diagram here of the ability to connect it up from the data port to a router as a service tool, or as an option. You can use could use a USB to RS-485 adapter as well to be able to go from your laptop with Connect and scan that trunk. So some options there. And if you don't know what I'm talking about, it's that little data port here in the bottom picture here, little 4-pin plug there. So, and that's about the meat of it for our kickoff on our networking series in BACnet. So we've got a little bit of time here. Do we have any questions, comments about any of the BACnet stuff? Or how about any questions or anything that y'all might like to see discussed in the networking series? Like I mentioned, we're gonna take a look next at Wireshark captures, and then follow it up with discussions with IT for the next month. But if y'all have any ideas or questions or things that you typically run into with networking that you'd like us to add in or discuss, we can do that. We can do this, because the goal of these Stuck on the Bucket webinars is to find the best information and answers for y'all that we can be providing for you. Let's see if I can pull the chat up. Billy, did we have any questions or comments come in? I think you're muted, Billy.
Yeah, there was a question from Adam. It said, did that graphic state the MSTP wire goes into the net sensor and not the controller?
That is correct. Yep. So there's a port on the bottom of the net sensor, and then some of the STE 6000 series. I believe it's a 6010, 6014, and 17 analog sensors provide a temporary MSTP connection with that 4-pin cable. And what that does is it goes through the room sensor port from the net sensor back up to the controller and connects you to the BACnet MSTP trunk that net sensor and controller are connected to. So it's a way, if you're in the field and you've got that cable, you can connect in and be able to look at that trunk that you're standing next to without having to get your ladder out and get above the ceiling to try and tap into the trunk there if the router is wherever else, the other side of the building, and you don't want to walk all the way down to the IT room. Something like that, you can use that data port to be able to get in and troubleshoot that trunk from right there. See.
There was another question, Fritz. Will asked, should the router be disconnected from the trunk when using the NetStat connection?
No, I don't believe that the router needs to be disconnected from that.
Well, he was asking about the backbone router. So yeah, probably the main router doesn't need to be disconnected.
Right.
This would be like a technician router that's connected into the net sensor for service.
Right. No, I don't think it needs to be disconnected there. The main thing there that you might run into is just setting up your service router or service tool router, making sure it's at a different MAC address, an IP, or not IP, but device ID. Well, really MAC address, because we're just looking at the BACnet trunk there, to make sure there's no conflict with your main router that's set up, permanently installed there. If they have the same MAC, you might run into an issue when you hop on the trunk at the net sensor, but otherwise you should be good. All righty. Anything else? Firefly note taker? Oh, no question. All righty. Billy, anything else to add?
Not at the moment.
Not at the moment. Perfect. Well, as always, if you have questions or are not sure anything, check out the KMC Controls YouTube channel and all the videos that we've got out there. If you ever have any topics you want covered, feel free to add them onto the LinkedIn post or send messages in via LinkedIn to the KMC Controls channel there or to my email. So our next webinar, I believe, is on June 27th. I want to be on the one on Wireshark captures. So that's it, Billy. Thanks for hopping on today. And thank you, everybody, for jumping on. Y'all have a great weekend.